Now we've covered some of the details of states of bodies and the types of bodies, we're going to move on to some of the operations that are available for modifying and creation of those bodies as well. So if we, in the design modeler interface, if we move to the left hand side and select the create button as shown here, we can drop down to all of the manipulation and creation tools for bodies. This is generally, after the new plane option, is generally split into 4 sections as shown here. The top section here, extrude through to thin surface for creation bodies, which requires some lower topology geometry in order to use as a basis for creation of the body. We can apply these blends or chamfers, which are applied to existing bodies by assigning them to edges and faces. And we can also modify using the third set here of tools. We can modify existing bodies to result in modified or new bodies as well. We've also got an option, primitives, at the bottom here, which allows a quick creation of some primitive shapes without having the need to generate the sketch in advance. So for example, if we didn't use the primitives and we wanted to build a cube, we would have to create a plane, create a sketch of a square on the plane, and then extrude the square into a cube. But if we wanted to create the cube from scratch without having to do the creation of the sketch, we could just identify, go to primitives and select the box or cube option and create it directly, and that would create all of the lower topology automatically without having to do it all manually. So the first option then at the top of the list is the extrude option. We'll go through some of the details on the extrude. Extrude is probably one of the more well used tools for body operations within Design Modeler. So it's useful to talk about some of the options available in the details view for extrude. So if we go to the details view, we can see on the top right here we have 3 key options for geometry, operation and direction vector. So the geometry is the base selection from which the extrusion is going to be applied. So this can be a sketch, a face, a name selection, and we can take any of these and identify them in this box here. And we simply left click on this box and drop down and then choose a particular entity, sketch, face, etc. And we can do that by just simply selecting in the structure tree the particular sketch or face we want to apply, or we can select in the GUI if we want to select a particular face, for example, for it to be applied. The operation is then, we have a number of different options available for this extrude, because it need not necessarily only be for sweeping out and adding material. We've also got some other options for cutting away into the existing material with this extrude option. So it's not simply just an extrude, it also has some Boolean capability there as well. So the options here are add material, cut material, imprint, slice, and also to add frozen. And the next few slides cover examples of all of these options, so you can try to understand how these actually work in practice. The third option listed is the direction vector, and this is essentially the direction for the extrusion. So by default it will be set as normal when the base object is set to sketch, otherwise you need to manually specify that. And that can be defined as simply selecting an edge or selecting another vector direction for the extrusion direction. You can also select the face itself and the normal for the face if you want to extrude normal to the face, if you need to do that as well. So here are some of the options for extrusion that are available, and they're listed down here as we saw in the previous slide. So we can add material, we can add frozen, we can cut material, imprint faces, and we can slice material. And the results of all of these types of options can be seen at the bottom here, with the base geometry being shown on the right hand side of the screen. So here we have this cube, which is 1 part 1 body, and it's an active body because it's opaque, and we have this sketch which has been created on a plane which has been created on the face of the cube. So the first operation then, if we add material, this will create a body, and because we're adding material and the original body is also an active body, then it will automatically agglomerate with the original body, as it can be seen here on the left hand side. So we end up with one part, one body in this case. Now this is because we've got coincident faces essentially on these two bodies. On this second example with add frozen, the second body is now a frozen body, and because one is frozen, one is non-frozen, then this means that they're not joined together and they are separate bodies. So neither of these bodies sees the other body, but they exist, and so they exist as separate parts because of that. So if one of these was converted from, if the frozen body was converted to a was unfrozen, which we can do as a separate command, then it would result in the example on the left hand side. But because it's added as frozen, then it's retained as a separate body. Now it doesn't matter whether bodies are frozen or not frozen. We're still allowed to generate meshes regardless of the type of the body. But the frozen and non-frozen state allows us control over retaining, it allows us to retain control over which bodies are sharing topology or sharing intermediate faces in this case with its associate neighbor bodies. So it's just a control, a level of control. The third example then is to cut material, so we can take that sketch and we can, in this case, extrude normal, and it will slice out material from the neighbouring body as shown here. Again, we're just slicing away the original material, so we're just left with a single body. And we can also opt to imprint faces, which will just take the sketch and imprint it onto the face, so we were left with multiple faces on this particular body, but at the end of the day we're still left with a single part, single body. And we can also opt to slice material, so similar to the cut material, except we're left with two frozen bodies, and neither of these bodies see the other body, so we're left with two parts, two bodies, because each part is basically a separate part, so neither can see where the other is. Now if those two bodies were sharing an intermediate face, then we'd have one part and two bodies, but as it is, because they don't see each other and because they're both frozen, then we have two parts, two bodies. Okay, so on the extrude direction option, you'll see you have a number of different options available. So on the right hand side here we can see details of extrude. We've talked about geometry, operation, direction vector, and then we also have this direction here, normal, reversed, both symmetric, both asymmetric. So we can extrude it in a single direction, normal to plane. We can reverse the direction just by selecting reverse, and it will switch it and flip in the other direction. We can have the extrusion performed in both directions and as a symmetric extrusion. So for example, we take this sketch and we extrude it in both directions by, in this case, 5 meters as a fixed extrusion. Or we can decide to do an asymmetric extrusion, such that we extrude one in one direction, for example 1 meters here, and the other in the other direction 5 meters. So there's an asymmetry in the extrusion. So it need not only be in one particular direction; it can be in both directions, and we can also control how far the difference between the positive and negative directions for extrusion as well. We can also choose an extent type. So here we are defining how far the extrusion will go on for, and we can specify a fixed value. So this is the default, and we manually specify how far the body will extrude. In the last example, it will be 1 meters or 5 meters, and it will extrude for that distance and then terminate. But we could also have some other options that we can choose for the extrusion extent type. We can also say through all, which allows it to pass all through the bodies, all through the elements up to the final entity, as shown in the center option here. So we can see it's gone through all of the parts, all of the body, up to the final entity of the body. And we can also choose the option to next, which will terminate at the first part of the next entity that it encounters, as you can see here in this first branch, and it stops. And we can also choose some other options on to particular faces and to particular surfaces as well. We can also control the extent type to surfaces and faces that we briefly described in the last slide, and here we can see an example of that. Here we've identified this particular set of faces, as it's been seen in this upper left image here, and then the extrusion will terminate at these particular faces. And a neat way for extrusion or controlling of extrusion is also up to surfaces, and we can identify where the extension of the surface would reach and effectively terminate the extrusion at that extension surface, even though that surface is not a created surface in terms of an existing entity where it would conventionally terminate. But we can extend an existing surface to imply a termination of the extrusion, as can be shown here in this lower right image, where we've terminated along this arced face where this arced face would be. Another option for extrusion is a thin surface extrusion, which can be quite a useful tool, especially if you have solid bodies, in order to build out into thick solid regions. So if we enable it, which is an option at the bottom here under as thin surface, which is default to no, we can switch this to yes, and then we'll have some options on inward and outward thicknesses. And here we can see we have a surface body, because this is just a surface that's maybe created from this sketch, but and here we have one part, one body, and the surface body, which is a member of this part. We can see this little icon with this surface identifying it as the surface body. Once we selected that for use as the extrusion, and we specified some values for inward-outward thickness, we can extrude it normal to the plane to essentially bring the surface out into a solid in the direction normal to the plane itself. So it's moving, it's coming radially outwards and inwards in order to build up that solid. So we go from a zero thickness into a non-zero thickness body. So that's useful for creating shell bodies, and yeah, we have some options for manually specifying thickness as well. There's also another sub-option under the extrude feature creation to merge topology. So basically we can, once the extrusion is performed, we can elect to automatically merge the lower topology after that body's been formed. So if we select yes, it optimizes the topology of the feature bodies. But if we leave it as no, it will leave all of those lower topology features there. So some tips that are given here. If the small face of interest during the meshing, if small faces are of interest during meshing, then we can set it to no. But if they are unnecessarily forcing for a fine mesh, then we can switch it to a yes, because that if we have all of these lower faces which are merged together as shown in this example here, it prevents us from being restricted with placement of the nodes. Because when we get to meshing, all of the mesh nodes will have to line up on all of these intermediate edges which make up these lower entities, to define all of these faces. And if that's really not needed, that's only used for the geometry creation as part of the extrusion of this sketch as shown here, then we don't need that, and we're not restricted. We don't need to be restricted from it as far as when we get to the meshing stage. So we can simply opt for yes, which removes all that, and also removes the need to have constraint of placing nodes on all of these intermediate edges. So it gives us greater control for meshing and growth rates, and there's no need for placing nodes on all of those edges.